Good morning, class. This is Mrs. Martinez, and we're going to do some review of the mole, atomic mass, the mass of 1 mole. We're going to go over a worksheet. I will do select problems, and then you will complete the worksheet. So let's review that. Just like 1 dozen equals 12 of anything, 1 mole equals 6.02 times 10 to the 23 of anything. So if I have 2 dozen apples, I have 24 apples. If I have 2 mole of something, well, how do I figure that out? I'm going to get my calculator. .02. This EE is times 10 to the 23 times 2 equals 1.2 times 10 to the 24th. These are big numbers, and these big numbers sometimes is what confuses us. That's why I want to keep referring back to a dozen. Just like 1 dozen is 12, 1 mole is 6.02 times 10 to the 23. If I have a half dozen, I have 6. Well, if I have a half a mole, what does that equal? Again, I'm going to go to my calculator. 6.02 times 10 to the 23 divided by 2 is 3.01 times 10 to the 23. So you will be assigned this worksheet, and in this worksheet you are being asked to do 2 different things. The first is to calculate the molar mass of this compound, and what that means is how much does this compound weigh if I have 1 mole? We come back here and we talk about the dozen again. If I have 1 dozen eggs, that might weigh 1.5 pounds. But if I have 1 dozen pennies, that might equal 12 grams. 1 dozen cars might equal 80 tons. So 1 dozen is the amount. That amount weighs something, and not everything weighs the same. Well, it's the same thing with your compounds. This compound, K3P, which you will have to name in this column, but I'll name it for you. I'll do the first one, is potassium phosphide. This weighs 1 mole of this is different than 1 mole of water, than 1 mole of salt, than 1 mole of donuts. So the count, what you are counting, has its own mass. So we're going to calculate the molar mass of these compounds. And I'll do the first one for you. And I want you to show work, just the way I'm going to show work. So potassium's atomic mass, and I go to my periodic table of elements, is 39. We're rounding. And that is times 3 because there is a 3 here. So it's 39 times 3. And that equals, I'm going to get my calculator, 117 grams. Now I need to know what the atomic mass of phosphorus is. And that is 31. And there's only one of them. So I'm not going to put times 1. So when I add these together, I get 148 grams. So now we need to determine what 1 mole of this compound is. Now let's just rewind. K3P, potassium chloride, is an ionic compound. How do I know that? Well, I know that potassium is a metal, it's on the left, and phosphorus is a nonmetal, which is on the right. But Cl2O7, those are 2 nonmetals, so that is a molecular compound. So when I name this, I have to use prefixes. So this is dichlorine, and heptaoxide. So now let's figure out how much 1 mole of dichlorine heptaoxide weighs. So Cl is 35, and there's 2 of them. So that's 70. And oxygen is 16, and the atomic mass of oxygen is 16, and there are 7, and 16 times 7 is 112. When I add these up, I get 182 grams. Okay, let's do the next one. The next one is also an ionic compound, tin. And this is a polyatomic compound. Remember, these guys exist together in nature. So this is tin. And just to throw a little bit more, this is tin's oxidation number. So I'm just going to do tin 4 hydroxide. So now we need to find the atomic mass of tin, which is 119. There's only 1 of them. And let's look at oxygen. So oxygen is in these parentheses. That means that there are 4 hydroxides. So oxygen's atomic mass is 16. There are 4 of them. That gives me 64 grams. There are also 4 hydrogens. Atomic mass of hydrogen is 1. There are 4 of them. So let's add this together. 9 plus 4 is 13. Plus 4 is 17. Carry the 1, 2, 8. 187 grams. So I'm going to skip these 2, 3. I'm going to go down here. So here is iron phosphate. So remember, iron is a metal and phosphate is a polyatomic ion, which happens to be an anion. This has a negative charge. Also, let's remember that iron is a transition metal. So we have to figure out what is its oxidation number so we can name it properly. So we know that iron's oxidation number is 2. So this is going to be named iron 2 phosphate. And let us now calculate the molar mass. How much does 1 mole, which means that you have 6.02 times 10 to the 23 of this guy. And when you have those many, how much does that weigh? So, iron's atomic mass is 56, and that is times 3. See this? There are 3 irons. So, 56 times 3 equals 168 grams. Phosphorus. Now there's a 2 outside, so that means that there are 2 phosphates. There are, so it looks like this. There are 2 phosphates connected to these 3 irons. When we add up the phosphoruses, there are 2. The atomic mass of phosphorus is 31 times 2 gives us 62. Now here's where people get a little jacked up. So there are 2 phosphates. If you count the oxygens, there are 8. 4 times 2 is 8. So 16 times 8 is 128. Now let's add this up. It's 10, 18. 6 and 6 is 12. 14 and the 1 is 5. 1, 2, 3. 358 grams. Okay. So I want you guys to finish these. And there's another page. Okay. So now let's do some calculations. We want to figure out how many molecules are there in 4 moles of glucose. So what do I have? I have 4 moles of glucose. I want you to show me work. When you write everything down, then you're not going to get confused what it is that you are looking for. You are looking for molecules. So my molecules are going to go on top. And what do I know? I know that 1 mole of glucose equals 6.02 times 10 to the 23. I should have written that out a little better. Molecules. This is something I know. If you don't know it, write it down. So now I have to multiply 4, because this is going to cancel. And that is the trick of doing these. If you write everything out, it's going to make sense. But if you try to figure out in your brain, it's not going to work. So, I have 4 times 6.02, 23, and there is my answer, 2.4. So how many molecules are there in 4 moles? 2.4 times 10 to the 24 molecules are in 4 moles. If you want to understand this, imagine that this, go back to your dozen. If you have 4 dozen, how many is that? Write it out. This will make sense to you once you write things out. Number 1 and number 4 are the same. So I want you to do number 4. I'll start it for you. 0.41 moles. You write everything out. If you write it out, then you're going to be able to cross things out and understand. The next one is, how many moles are in atoms? 1.205 times 10 to the 25 atoms of phosphorus. So what do I have? 1.205 atoms of phosphorus. Well, what do I know? And what do I want? I want moles. So moles is going to go on top. And what do I know? I know that 1 mole is equal to 6.02 times 10 to the 23 atoms of phosphorus. I take this, I divide this by this, and now that's going to give me my answer. So I want you to figure that out. I set it up for you. This is asking how many atoms are in 0.750 moles. Here's 0.750 moles of zinc, and they want to know how many atoms. So what do I know? I know that 1 mole is equal to 6.02 times 10 to the 23 atoms of zinc. Cross this out, and there's an answer. Okay, I'm going to do a couple of these and leave that rest for you to do. How many moles in 28 grams of carbon dioxide? So now we're going from moles to grams. So I have to go back and calculate molar masses. So what do I have? 28 grams of carbon dioxide. I want to know how many moles. So I'm going to put that on top. So I have to figure out what 1 mole of carbon dioxide is. What is the molar mass of carbon dioxide? So carbon is 12. Oxygen is 16 times 2. 44. So 1 mole of carbon dioxide is 44 grams of carbon dioxide. 28 divided by 44 will give me 0.64 moles. Now this makes sense, right? Because 1 mole of carbon dioxide is 44 grams. If I have 28 grams, that means I have less than a mole. That's what that number is. Okay, let's do the next one. I have 5 moles of iron oxide. Iron 3 oxide. I want to know what the mass is. Okay. So what do I know? I'm going to set up my problem. And I have to figure out what the mass of 1 mole of iron oxide is. So, Fe is 56 times 2. I should do this in my head. It's 112 grams. And oxygen is 16 times 3, which is 48 grams. So 1 mole of iron oxide is 160 grams of iron oxide. This gets crossed out. And now I multiply 5 times 160, and that is the mass of 5 moles of iron oxide. I'll do it for you. 5 times 160 is 800 grams. So right here we want to know the number of moles of argon and 452 grams of argon. Okay, so I want you to try that one. Find the grams in 1.26 times 10 to the negative 4 moles. Ooh, let's do this one. Okay, I'm hoping that you are looking as I do this work. The best thing you should be doing as I'm going through this, pause your Chromebook and look at what I'm doing and try to figure out how you can get the answers also. I am doing some calculations over here. I don't know if you could hear my dog in the background. Okay. So we're finding the grams in 1.26 times 10 to the negative 4 moles of this compound. This compound, by the way, is acetic acid, otherwise known as vinegar. Notice this is a small number, so this is going to be a small number. So when I add these up, I have 60 grams of acetic acid equals 1 mole. I want you to notice that all I did was add up all the atomic mass of all the elements. That equals 60. 60 grams equals 1 mole. So what am I going to do now? I'm going to multiply this number . 1.26 times 10 to the negative 4 . Let me make sure I did that right. 1.26 EE times 60. So So that is how many moles. That is how many grams of acetic acid there are when I have this many moles. I'm left with grams. So that is the unit that I'm going to use right here. Find the mass in grams of 2 times 10 to the 23 molecules of F2 difluoride. So 2 molecules, 2 times 10 to the 23 molecules of F2. This one's a multi-step one. So 6.02 times 10 to the 23 molecules equals 1 mole. And I also know that 1 mole of F2 equals 38 grams of F2. The atomic mass of fluorine is 19 times 2. So this is a two-stepper. So molecules gets crossed out, moles gets crossed out, I'm left with grams. I want you to figure that out. Okay. I want you to fill out the rest. Here's a problem. On NutraSweet, I want you to figure out the molar mass. Here is the chemical formula. Then how many moles. These are all things that you can do. I am going to post this. I'm going to post the answers day after I put this on the classroom. And once I post the answers, then we're going to have a quiz on this and move on. I want to take a second, however, and look at the brain pop that a lot of you were saying you didn't know how to do the worksheet. So the worksheet is asking you to do 3 things. Determine the chemical formula. The chemical formula for ozone is O3. It tells you right there. There's oxygen, 1, 2, 3. So O3. The atomic mass, in this case, you're only determining the atomic mass of one element, oxygen. So oxygen's atomic mass is 16 grams. The mass of 1 mole of ozone is 16 times 3, which equals 48 grams of ozone. The next one is asking you for the chemical formula of NH3, ammonia. You can write that down, NH3. The atomic mass of nitrogen get your periodic table out. Is 14, and the atomic mass of hydrogen is 1. The mass of 1 mole is 14. There's only 1 nitrogen, plus 3 because there's 1 gram of hydrogen and there are 3 of them. So this equals 17 grams. The last one they're asking you to do is hydrochloric acid. I'm going to leave this blank so that you can do this, but I also want to bring your attention to the fact that there is an answer key. So it does show you the answers. Okay, so now that you understand how to do it, and you see that there's an answer key for you to check your work, please go back and complete that part of the brain pop. All right, guys, have a great day.